Today, I'm going to be talking about Venus. No, not the razor brand, and no, not the clothing company either. I mean the planet, because, let's be real, it's much cooler than either of those other things anyway. Venus is the second planet from the sun and the sixth largest in the solar system. Notably, although it's not the closest to the sun, that title goes to our little buddy Mercury, Venus is the hottest. This is because its thick atmosphere traps a lot of heat. Venus is named after the Roman goddess of love and beauty, and it's the only planet named after a female god. Many of the features on Venus are named for women. The planet has always been visible to us. It gets closer to Earth than any other planet in the solar system, and its atmosphere is very reflective. This makes it the third brightest object in the sky behind the sun and the moon. Its brightness and radiance in the sky may be what made the Romans name it after their goddess of beauty. Venus is often called Earth's twin because the two planets share a lot of similarities, but when you take a closer look, it's almost like the two planets couldn't be more different. Venus orbits the sun at an average distance of about 67 million miles. Of all the planets in the solar system, its orbit is the closest shape to a circle, so its closest and furthest points from the sun don't vary that much from this average. Because Venus is so close to the sun, it often appears close to it in the sky. This causes it to appear around sunrise and sunset, much like Mercury. To the ancient Egyptians and Greeks, Venus was known as both a morning star and an evening star. Venus spins incredibly slowly. Her day is about 243 Earth days long. This is longer than her year, which stands at about 225 Earth days. Venus and Mercury are the only two planets whose days are longer than their years. I wonder what calendars would look like for them. Venus's proximity to the sun causes it to have phases similar to the moon, although these can't be viewed with the naked eye. Compared to most planets in the solar system, Venus spins backwards. The only other planet that does this is Uranus. Because of this retrograde spin, on Venus, the sun would appear to rise in the west and set in the east. Venus's odd rotation could have been caused by a collision with another object in its early history. With an axial tilt of only 3 degrees, Venus experiences no noticeable seasons. One of Venus's most prominent features is its incredibly thick and dense atmosphere. This atmosphere is mostly made up of carbon dioxide, and it's responsible for the planet being as hot as it is. It also makes the sun look like just a smear of light from the surface. Venus's surface pressure is 90 times that of Earth's due to its atmosphere. Winds in the upper atmosphere move at speeds of 110 to 220 miles per hour. That can go above a Category 5 hurricane on Earth. If you've seen my video on Mercury, then you probably know that its lack of an atmosphere is a huge reason for it being littered with impact craters. Venus, on the other hand, has an atmosphere so thick that it slows or stops most incoming objects. Sometimes an object breaks apart in the atmosphere and causes clusters of impact craters. That's pretty neat. Venus has no internally generated magnetic field. This is possibly due to its very slow rotation. Instead, it has what's called an induced magnetic field. This is caused by the interactions between Venus's outer atmosphere and the sun's magnetic field. Ultraviolet light from the sun excites gases in Venus's outer atmosphere. These excited gases are known as ions, and they create a region called the ionosphere, which is something that Earth also has. The sun's magnetic field then interacts with this ionosphere to create Venus's induced magnetic field. This field is shaped like an extended teardrop. Venus is almost as big as Earth, with an average diameter of about 7,521 miles. By comparison, Earth's average diameter is about 7,917 miles. The two planets are also similar in mass, with Venus being about 80% of Earth's. The planet's interior structures are also very similar. Venus has an iron core wrapped up in a mantle of hot rock. On the outside is a thin, rocky crust, but go beyond these similarities, and Venus and Earth are very different. The surface of Venus reaches temperatures as high as 900 degrees Fahrenheit, which is hot enough to melt lead. Combine this with the high pressure, and if you went to Venus, you would basically be pressure cooked. Few spacecraft have landed on Venus's surface, and none have survived more than a handful of hours. Venus's surface is a barren, dim, and rocky landscape. From the surface, the sky appears yellow because of the sulfuric acid in the atmosphere. This surface is also relatively new. new. Most features have an average age of about 150 million years, which, don't get me wrong, is a pretty long time, but it's almost nothing compared to the entire lifespan of Venus. Besides Earth, Venus has the fewest impact craters of the terrestrial planets. There are a couple reasons for this. For one, its thick atmosphere can stop many incoming objects before they ever hit the surface. But even if something does make contact and hit the surface of Venus, the volcanic activity that's constantly reshaping the planet's surface could have erased it. Venus's surface displays valleys, high mountains, and thousands of volcanoes. Because of the planet's high heat, it also has spots of impact melt. This is molten material ejected from impacts that leave a crater, and they can stretch for very long distances. A lot of Venus's features are named after both real and fictional women. There's a volcanic crater named Sacagawea after the Native American woman that aided Lewis and Clark on their expedition. A deep canyon is named after Diana, the Roman goddess of the hunt. The Ishtar Terra is a rocky highland area at the North Pole. A similar region stretching across the equator is called the Aphrodite Terra, which is funny because Aphrodite is Venus's Greek equivalent. Venus displays the greatest diversity of volcanic features among the rocky planets. Over 80% of the surface is covered in volcanic plains less than 500 million years old. So, yeah. Suffice to say that Venus is not actually so similar to Earth. Venus and Earth share many similarities. Their size and mass are close, and they both reside within, or are very close to, the Goldilocks zone or the habitable zone. This is the distance from the sun at which conditions are right for life as we understand it to exist. But when you take a closer look, obviously Venus and Earth are very different. One hosts abundant life, while the other is covered in thousands of volcanoes and is hot enough to melt lead. Studying Venus more closely gives us a better idea of why it's unable to support life and why Earth can. Venus may once have been a habitable planet, but this was at least 1 billion years ago. A runaway greenhouse effect trapped a lot of heat from the sun on Venus, and this heat caused all liquid water to evaporate into vapor that then slowly leaked into space. Water is absolutely necessary for all life on Earth, so without liquid water, life simply can't exist. However, life on Venus is technically not completely ruled out. Among the clouds higher up in its atmosphere, conditions are a bit more favorable. About 30 miles up from the surface, temperatures range between 86 and 158 degrees Fahrenheit, which is still pretty warm, but favorable for certain types of life. The tops of Venus's clouds have these odd dark streaks that persist despite high wind speeds. These streaks absorb ultraviolet radiation. Most explanations for these streaks involve fine particles, ice crystals, or a compound called iron chloride. A less likely explanation posits microbial life as the cause for the streaks. If there is any life on Venus, then it would probably look a lot different from life on Earth. But without any liquid water, it's most likely that there's no life on Venus at all. Venus is one of 2 planets in the solar system that has no moons, with the other being Mercury. With Mercury, the reason it has no moons is pretty simple. It's small, so its gravitational field would have trouble grabbing onto something in the first place, but it's also very close to the sun, so the sun's powerful gravity could easily just pull any potential moons out of orbit around Mercury. With Venus, however, it's a little more complicated. It's bigger than Mercury, so its gravity would have a easier job grabbing onto something, although it is still close enough that the sun could yoink away any moons. In fact, there's a theory that says Venus did have a moon at some point. This moon would have resulted from a collision with another object, much like how Earth's moon formed. So why doesn't Venus still have this moon? Remember when I mentioned Venus's retrograde spin earlier and how it's probably due to a collision with another object? This very same collision could have caused Venus to lose its moon. Prior to this collision, Venus would have rotated in the same direction as most other planets in the solar system. At this time, it transferred rotational energy to its moon. This process caused the moon to slowly drift further away, and in fact, this is what's happening with Earth's moon. Then something hit Venus and switched the direction of its rotation. This switch caused it to stop transferring energy to its moon and instead to absorb energy from it. Thus, the moon slowly fell towards Venus rather than drifting away. Once the moon was close enough, Venus's gravity pulled it apart, and it crashed into the surface as debris. So yeah, Venus might have once had a moon because it got hit by something, and then it got hit again, started spinning backwards, and ate its moon. That's pretty nifty. Unfortunately, Venus has no rings. None of the terrestrial planets do. It seems like cool rings are something only the gas and ice giants of the solar system get to have. Venus in retrograde is mostly something you probably hear in relation to astrology. I explained what it means for a planet to be in retrograde in my video on Mercury, and for Venus, it works exactly the same way. Retrograde movement is an illusion that makes it look like a planet is moving backwards across the sky. Because Venus is between Earth and the Sun, and because its orbital period, or its year, is shorter than Earth's, it sometimes overtakes Earth in its orbit. This makes it look like Venus is moving backwards, although its direction of movement hasn't actually changed at all. A transit of Venus, on the other hand, is something different. On occasion, Earth, Venus, and the Sun line up just perfectly so that it seems like, from Earth, Venus is moving across the Sun. This is similar to a solar eclipse, when the moon goes in front of the Sun. Transits of Venus are way less common than transits of Mercury. They occur in a weird kind of pair of pairs. First, two transits happen in December, around 8 years apart. Then, about 121 years and 6 months later, another pair of transits happen in June, once more 8 years apart. Wait another 105 years and 6 months, and the cycle repeats. The most recent transit of Venus happened in June of 2012. The next transit won't be visible until 2117, which means I unfortunately missed my only opportunity to see a transit of Venus in my lifetime. Well, at least there's still transits of Mercury. Mercury and Venus are the only two planets whose transits we can view because they're within Earth's orbit. Since all the other planets are outside of our orbit, it will never look to us like they're going across the Sun. Earth would appear to transit from other planets though, so that's pretty cool. I don't really have much left to say about Venus at this point. I've covered all the information I set out to explain. In my Mercury video, I did talk about some of the missions to the planet, but I didn't do that this time. Venus has had far more missions to visit and study it than Mercury, so if I tried to cram them all into this video, it would end up way longer than I want it to be. I think Venus is pretty neat, but that's probably not news to anyone at this point. Thanks for joining me on this journey to explore Venus, and for sticking around to the end. I hope you enjoyed, and I'll see you next time.